In today's world, security is of utmost importance, especially in educational and commercial buildings. Traditional lock and key systems offer the security demanded by society, but often at the price of convenience. Therefore, the search continues to provide a system that is both convenient and secure.
The most commonly used electronic locking system is the radio frequency identification, or RFID method. This system utilizes plastic RFID tags, such as this one right here, which can be scanned in order to unlock a door. While the plastic key cards are convenient, the back-end RFID technology is unencrypted and prone to security threats. For example, a hacker can buy a sub-$100 RFID scanner and when placed in the proximity of an RFID card, can make an identical copy, granting the hacker the same access. Because of this vulnerability, we needed a new system that conveniently and securely allows users to enter commercial and educational buildings.
Our solution is S.W.O.L.E, a secure, wirelessly operated lock environment that truly combines the best of both worlds. S.W.O.L.E operates similarly to the RFID systems, except it uses near-field communication, or NFC technology. NFC is a communication protocol that takes advantage of a default 256-bit encryption, making it significantly less vulnerable to exploitations. S.W.O.L.E also uniquely implements a complementary Android application that gives administrators the ability to quickly change key access permissions.
Let's say that this is a door to a faculty lounge in a school. The administrator's Android application, which would be used by the building manager or school principal, can determine what keys can be used to unlock this door. Currently, it is set so that only key 1, the teacher key, can unlock the door, while key 2, the student key, cannot. Now, the administrator will change permissions so that key 2, the student, may now enter the faculty lounge and beg his engineering teacher for extra credit. As you can see, the administrator was able to quickly change access permissions and sync through his Android phone.
On a more serious note, the most important and innovative feature of our product is the lockdown mode. This mode allows the administrator to lock every door and disable every NFC key associated with the system. This feature is particularly useful in a school setting if an intruder enters the building or gains access to a valid key, as current lockdown procedures require teachers to manually lock their doors, wasting precious seconds. All the administrator has to do is press one button, and the system will move into the lockdown mode.
The internals of this project include the Raspberry Pi microcontroller, which takes advantage of the C libraries of libNFC and Wiring Pi. Connected to the Pi is an Adafruit PN532 NFC reader, which detects when a valid key is scanned. This then sends a signal back to the Raspberry Pi, where the code will send a signal to our 3.3 volt relay circuit, which converts the 3.3 volt output to a 12 volt output for the lock. The system runs off of a 120 volt AC outlet and also has a built-in backup power supply that can be charged when necessary.
As current high school seniors, we decided to tackle a problem that was close to all of us. After discussing the idea during our senior project brainstorming sessions, we approached our school principal, Dr. Linda Russo, and asked her to be our potential customer. Along the journey, she has provided us with invaluable input.
Overall, after working on the project throughout our senior year with our engineering teacher, Mr. Enzo, we've come to realize that the project has real potential as a product to enhance both security and convenience in our lives.
As a result, we plan on pursuing a provisional patent and also continuing the project in college. Thank you for all of your time, and remember, always stay S.W.O.L.E.